What are common interfaces for in-orbit satellite servicing? Imagine a world where satellites can be repaired, refueled, or upgraded without coming back to Earth. That's the promise of in-orbit satellite servicing. But how do servicing spacecraft connect with satellites in space? The answer lies in the use of common interfaces. These are standardized connection points that make satellite maintenance possible and safe. They act like universal adapters, allowing different spacecraft and satellites to work together smoothly. One of the most important interfaces is the docking and berthing system. Think of it as a space version of a plug-and socket. It allows a servicing spacecraft to physically attach to a satellite securely. These docking ports are designed to align perfectly and lock in place, ensuring a stable connection. Standardized docking ports are being developed to work across many satellite types, making servicing more efficient. This means a single servicing vehicle can work with multiple satellites, saving time and money. Refueling interfaces are another key part. These are special ports that let a servicing spacecraft transfer fuel into a satellite's tanks. They need to be leak-proof and safe, especially since fuel can be volatile. Many older satellites weren't built with refueling in mind, so robotic arms and custom tools are often used to access fuel valves. Future satellites are expected to include dedicated refueling ports, which will make these missions faster and safer. Robotic manipulation interfaces are also vital. These are attachment points or fixtures on satellites that robotic arms can grasp. They help with tasks like repairing components, deploying solar panels, or replacing parts. These interfaces support robotic arms that can perform maintenance even on satellites not designed for it. This expands what can be done in space and extends satellite lifespans. Electrical and data interfaces are used for upgrades and diagnostics. Servicing spacecraft connect to a satellite's power and data systems through electrical connectors or wireless links. This allows for software updates, system checks, and troubleshooting. Using standard communication protocols and connectors helps different spacecraft and satellites communicate effectively. Finally, modular and assembly interfaces are designed for future satellite architectures. These allow entire modules or instruments to be added, removed, or replaced in orbit. They support on-orbit reconfiguration and upgrades, helping satellites adapt to new missions or technology improvements. Practical uses of these interfaces include extending satellite life by adding propulsion modules, refueling to restore fuel tanks, repairing or upgrading systems, removing space debris by capturing defunct satellites, and repositioning satellites to new orbits. The trend in the commercial space industry is moving toward a shared, standardized system of interfaces. This makes satellite servicing more routine, safe, and cost-effective. Developing these interfaces is essential for creating a sustainable space economy where satellites can be maintained and upgraded in orbit. In summary, common interfaces for in-orbit satellite servicing include docking ports, refueling connectors, robotic fixtures, electrical and data links, and modular assembly points. These connections are the backbone of future satellite maintenance, supporting a more flexible and resilient space industry.